So same as in C, if you have, say, an integer,
Something like this. Plus.
oh, but there's a thing in between.
Yeah.
Yeah.
I don't know.
So plus is just multiple, plus is concatenation. So quote ABC plus I plus details plus DEF plus J it'll make sense once it comes up. That's the power of my mind. Project my image onto the screen. Maybe I have to hit some keys. Here we go. You can see it coming. Yes. All right, so if you say like something plus something plus something plus something, it basically just strings them all together in a big long string. Right, so if I happen to be an integer that was equal to 5 and j happened to be an integer of 22, this would be the same as A, B, C, 5, D, E, F, 22. So I've been using it for output, right? I've been outputting something like, you know, I equals plus I plus j equals plus j, and that output I equals 5, j equals 22. So it's just a way to see the values of variables, for example. It's what we used to do with printf with lots of percents.
That's a very powerful thing.
It's more powerful than you know. We're going to see why in a little bit, because this thing is doing some really cool stuff.
Does Java have a string concatenation?
Does what?
String concatenation?
Yes.
Start 6 out of it.
So, well, you can use a plus sign, but we'll see another way in a second.
Okay.
Anyone want to do Boolean logic? We can do a state machine. All right, so let's do some code. Pay no attention to this. Keep not paying attention to this. Okay, you can pay attention. So strings are a thing in Java. They're their own data type. I can define a string data, and I can set it equal to a collection of characters like this. And data is this string that says, hello, this is fun. And we can use print line to see what the value of data is. And I'm going to put angle brackets around here so we can actually see where this thing begins. So I'll print out data equals angle bracket, and then I'll print data, and then I'll print out an ending angle bracket. So let's compile that, and let's run it, and it tells me data equals, hello, this is fun. So that's kind of cool, but there's something more going on. So string, right, when I declared data, I said string data. string is a type of variable, but it's an uppercase letter, which is a hint to us that it's actually a class. Just like rectangle was a class, uppercase R. So go to Google and Google string class, or maybe class string, and look for something from Oracle. This would be the first entry that Google finds. And you find a page that looks like this. It says class string. This is the documentation on this class called string. And every class that we work with in Java has a documentation page that looks like this. We can go to all classes, and it shows us all the classes that are out there. There's no rectangle class listed in here, but there's a few other classes in here. So when you say system.out.println, system is the name of a class. And I can click on that. There's the documentation page for the class called system. And all of these documentation pages have the same look and feel. It's standardized. If there's fields that you can get to, it tells you about the fields. Hey, there's a field called in. That's the in part of system.in. That's the out part of system.out. This is telling us that system.out is a print stream. It's another type of object. And what's a print stream? Well, we can find the documentation for the print stream class. And if we look at the print stream class and we look at the methods that are available, guess what? There's a method called println. And it takes booleans, characters, arrays of characters, doubles, floats, integers, and so on and so forth. And this documentation is standardized to the point where when you write your own classes, if you write your comments the correct way, you can run a command called javadoc. It'll read your source code and it'll produce this. And now you got this beautiful documentation on your classes in this exact same format, the same pieces, the same style, and so on and so forth. And if you're working in an IDE, you don't even have to do that. It'll just like do it for you. It'll like leave you templates and like, you know, type in what this function does here and you get all of this stuff. All right, so this is the class that we call string. So this documentation always tells you how to construct these things. And it turns out with Java we can also construct a string by doing this equals and then write a quoted string. But we could have said string data equals new string parentheses, hello, this is fun. And that would have worked fine. In fact, let's do that. So string data equals new string, hello, this is fun. And it does exactly the same thing. So what were we doing? We were doing a constructor which takes a string. And it initializes the newly constructed string, so it represents the same sequence of characters as this input. So multiple constructors for most of these things, just like our rectangle. We ended up with 2 or 3 or 4 constructors yesterday. But then there's also a set of methods. This is code associated with an object of this type. So once we have a string, that string, hello, this is fun, has a bunch of code we can execute. For example, we can say what's the character at some position. We saw this yesterday. What's the length? So length says, tell me the length of the string. So let's try that. Well, how do we find the length of data? Data.length. And we need the parentheses at the end to say this is a function, it's a method, not just a field like a variable. And the way to think of this is there's a piece of code sitting inside, right? Data is not just this collection of letters, it's also got a whole bunch of code waiting to be executed. And when I do this, I'm saying, okay, go to that piece of code called length and run it. and it'll return an integer, which should tell me how long that string is. So if we run that, it tells me data's length is 17. So here's a replace all. Replace each substring of the string that matches the given regular expression with the given replacement. Well, that's kind of cool. That's our 224 colon substitute statement in VI or in sed. And we can do it on any string for free. So let's replace every occurrence of a space with the string ha ha ha. That would be a pain to do in C. You can do it. That's like a final exam test question in C, if I'm in a mean mood. Because it's a lot of work, right? You have to move through your input string with one index. You have to look for a space. And then when you find it, you're copying the input to the output. When you find a space, you skip over it and you replace the output with a string. So you copy that new string in and you bump up the pointer. And you skip over the input space and you keep going, and then when you get to the end you write a null terminator on the end, or you forget and you get a seg fault, right? And here it's like, it's just this.
Really short.
Really short. And really easy to read, right? Instead of having 15 lines of stateful code and pointers and temporary variables. Pretty clear what I'm doing here. I'm replacing all occurrences of space with ha ha ha. And this is what life is like with Java, right? Or with any object-oriented language with a decent set of packages. If we want to convert this to lowercase, it's just data.toLowercase. And that'll return a string, which is a lowercase version. Trim gets rid of spaces in the beginning and the end, and so on. So be careful of this, right? This does not actually replace the contents of data. If you look at replace all, it says it returns a new string, which has that replacement done. If I just do this, I suspect it may not even compile. No, it does, but it doesn't do anything. I mean, it did. It removed the spaces, replaced them with ha ha ha, built a string, returned the reference to that string, but I didn't do anything with it. So data hasn't changed. All right, so here's a simplified version. So I didn't have any spaces, so data started off as just hello. It's still equal to hello. So let's do some equalities. Typing is sad.
System out in that line.
System. There we go. Thanks. All right, so my string is equal to hello. I do that replacement. Nothing gets replaced, so my string is just hello. And then I'm going to say, is my string equal to hello? And if it is, life is good. Otherwise, sadness rules for 20 seconds. So compile that and run it. And guess what? My data equals hello failed. And I already described this yesterday. What's the problem here? It's a 224 problem.
You're checking the exact line.
Yes.
So
I'm
this
checking to see if two objects are the same. Data is an object. Quote hello is an object. It's a string. Data is also a string, but they are not the same string. This is where data is. This is where quote hello is. They're not the same. I have two different objects. They happen to have the same letters inside, but they're not the same object. And that's what equals equals is checking. This is just like comparing strings in C. You have two pointers and they're pointing to the same collection of characters, but if you say equal equal, you don't get back equality. So in C, what do? We use string compare. And that says look at the contents of these strings, see if they match up. So same thing with strings in Java. We have a function called equals. So equals will take a string, test if this string ends with the specified suffix. That ends with equals. Compare the string to the specified string. You can click on all of these too and get a slightly longer description of them. So instead of saying if data equal equal, we'll say if data dot equals quote hello, then tell us life is good, and so now life is good.
so does it count the terminator?
There's no null terminators. There's none of that weird stuff from C anymore. Which is good. All right, so when we start working with a new class, usually at some point you want to go through the documentation, find the Java doc, right, from Oracle, and browse through it. Nobody reads these things, people search these things. People say, I'm looking for such and such in this class, and you just look for it with a control F or something, and you find it, and you go from there. And it's all hyperlinked, right? So I can look at contains, and I can see what a character sequence is, and that's implementing a string builder, and so on and so forth. And we'll come to this set of pages frequently throughout this course, because I don't remember most of this stuff, and especially people who use IDEs never remember this stuff. So it's all documented. All right, so let's look at this weird toString thing. Here's this method called toString, and it returns the string itself. So why do we have a function that just returns the argument? It's like the yup gate in 250, or the wire. So let's look at this. And I did this in the earlier class, and I copied that code over to Canvas, so it should be there. Similar, but different. So let me simplify this. So let's call data.toString and see what that's equal to. Right, and not surprisingly, it's the same as the original string. That's what the documentation tells us is going to happen. Well, it turns out that every object has a toString method. Strings have a toString method. Scanners, print buffers, system, everything has a toString method. So remember our rectangles from yesterday? Let me call it data. And hold on a second. Okay. So rectangle class is still there from yesterday. We can construct a new 5x7 rectangle. Let's call the toString method and see what it returns. We didn't write a toString method, but there's always a toString method in every class, so rectangle should have one. So let's try this. So we run this and it says data equals angle bracket, and this is what toString returned, rect @ weird hex number.
Where is this number from?
Yeah, where is that number from?
What was rect?
It was a 5x7 rectangle.
No, what is the class rect?
That's the one from yesterday. So that's this thing. It's got a height and a width and some constructors and an area function. And I think a square me function at the bottom. Yeah. And some setters and getters. So let's make a new rectangle, data 2. We'll make that a 10 by 10. And let's see what that converts to. And so data 2 is rect @ some totally different weird hex number. So this is pretty unuseful. Rect is apparently the name of the class, right? @ is always there. And then this hex number is some sort of internal code that the JVM is using to identify this object. It's kind of like a memory address. But remember, this is running on a virtual machine, the JVM, and it's got its own notion of where to store things and so on. So let me show you something a little weird. If I just do this, if I just say print out data equals and then concatenate data and then concatenate a greater than sign, data is a rectangle, right? It's not an integer, it's not a string, it's a rectangle, whatever that is. But when I run this, I get exactly the same output. So what's our hasty conclusion? When we concatenate something that's not a string, the JVM calls the toString method to turn it into a string, and then it concatenates that. And this is really useful because it means that we can print out rectangles, fractions, vectors, whatever classes we're making, linked lists. We can print them out and concatenate them to other things, and it will do something so at least it doesn't blow up. Right? It's not trying to literally add a rectangle to an angle bracket. It's turning it into a string and then printing that out. But this output we're getting is not terribly useful to us. Well, it turns out there's something we can do when we write a class. We can write any method that we want in here. In fact, we can make a method that returns a string and takes no arguments called toString. And this will overwrite the default toString that's always contained in every class. So we can specify for ourselves our own toString. So I'm going to make a new toString. It's just going to return the string wow. And now when I print out data and data 2, it tells me they're equal to wow. Not useful, but this tells us how to do something very useful. So how should we print out a rectangle? If someone wants to print my rectangle, what should I have them print out? Besides wow or rect @ weird hex number.
A rectangle?
Okay. Should we include the dimensions? We'll be nice and include the dimensions. A rectangle, comma, height by width. Well, just by writing that one line of code in this class's toString method, if I run that same main method, now I got something pretty reasonable. Data equals 5 by 7, data 2 equals a rectangle 10 by 10.
Huh.
That's pretty nice. Now if I implemented my linked list code, or my binary tree code, and I wrote a toString method in there that traversed my data structure and printed out the nodes with commas in between them, in my main program I could create, I could say Nick's linked list space L, and I could say L dot add this node, L dot delete that node, and then if I said print line L equals plus L, it would call my traverse code, it would do the recursion, all that stuff, and it would print out a nice comma separated list of nodes. And it looks like I'm printing a list, right? Whatever we want that to mean, we can set up this toString method to do that. So this is cool. This is along the lines of being able to make a class that other people can use that has, things that are useful, and certainly being able to print the contents of your object in some meaningful way is pretty useful. And whoever is using this doesn't need to know anything special about what your traversal code does. They just say, print line data. I'll show you one oddity though. We'll talk about this later, but just in case it comes up. If I do this, oh, never mind.
Couldn't get a computer.
Huh, okay. I think if you do that with, sometimes when you do this it'll complain and say that that's not a valid argument to print line, but apparently it is. Okay, I'm thinking of something else. Alright, so that works. That's an even better example.
Could it be an empty data or a data that doesn't have a?
If data is null, then it can't call.
toString?
So this will get all kinds of unhappy because it's going to try to find the toString method of a null object. Oh, but it's smart. But if I try to do this, right, if I try to call a method on there, this is going to blow up. I insist. There we go. There's your null pointer exception. A lot of Java really tries to save you from yourself. This is another counterpose to C. C happily does whatever your code says, right? Even if it's some horrifying thing. Java works really hard to kind of like protect you, which can be annoying or it can be useful at 3 a.m. So if you don't initialize a variable, it'll refuse to compile. It'll say this variable is not initialized. If you have a variable and you don't actually use it anywhere, it'll usually give you a warning to remind you that, oh, maybe I should have used some other variable somewhere. Let me show you one other string thing. This is run. This is fun. Okay, so there's this. This is a useful method. It's called split. So split takes a string, it looks for that string inside the original string, and everywhere that it finds it, it takes everything before that and it pulls it off and it throws it into an array. And then it looks for the next occurrence and it takes everything between those first and second occurrences and it throws that into the next spot in the array. And it basically takes a string and chunkifies it, splits it into pieces, and builds an array with each of those pieces. So, simple example. Here's our original string. It's got some spaces. String data, string bracket bracket, right? Just like in our main method, equals s.split. Let's split it at the spaces. So this should go into the split method on this string. This is fun, yes, goodbye. Should look for spaces, take everything between the spaces and put them into consecutive elements in an array. And it returns that array, and I'm setting this string array called data equal to that result. So this one statement should build an array containing each of the words in that sentence. Did we do this yesterday? No, we didn't. We did args. So we can find the length of an array by just looking at the length field. So I equals 0, I less than data dot length, I plus plus. I'm not proud of the fact that I can write lines like that. So I'll print out data bracket 0 equals, and then I'll print the value of data 0 in angle brackets. And we'll do that for all the elements in the array up through data.length minus 1. And just see what got stored into the data array. And it just split our string up. This is really, really useful. And also pretty painful if you try to do this barehanded. But when you do this, right, you're running a piece of code that does all of that stuff, that goes through and has pointers and is stateful and knows if it's looking at stuff in between or looking at separators and putting them into array outputs and so on and so forth. That's all coded up inside the split method of the string class, and you get it as part of constructing a string. So it's not magic, it's just this code has been done and you're reusing it. Yes?
It's kind of like what happens when you look at string args.
Mm-hmm.
Args, it splits it
Yeah.
into an array.
Yeah.
Of string.
Yep, yeah, so there's probably a call to split somewhere in the beginning of the JVM. All right, so that's sufficient to get you going on PA1. So let's talk about PA1. So PA1, you're going to implement your own class. It's going to be called fraction. And it's a class for implementing fractions, rational numbers. And the goal is, when you're done, you can say, you know, integer I, you can say double x, you can say fraction f. And f is this thing that has a numerator and a denominator. And if you have a fraction equal to 1 over 3, it remembers that it's 1 over 3, not 0.3333333, which is imprecise. So it's better than doubles in some ways. So you're going to create this class, and this is what you're going to submit, is the fraction class. You're not going to turn in a main program, but you're going to write some main programs to test this as you're developing it. Before you start doing this, though, you should be playing with the stuff that we're developing in class, right? So I'm posting code over in that area that you can get to from Canvas. You should be compiling code, making changes to it, seeing what it does, writing your own extensions to it or your own versions and so on, just to get the feel of this stuff, right? Even if what we're doing here makes perfect sense, you want to get your hands dirty as soon as possible. So if you haven't started typing in Java, C, Java, start doing that, right? And get some practice with that before you jump into this, unless you really just want to sort of see if you can do this, right? But chances are you'll have more success if you start with some smaller pieces and get those nailed down so that when you're doing this, you're not trying to figure out how do I define a class, right, for the first time. So, so you're making a class called fraction. It's got a pair of constructors. Okay, you can construct with a numerator and a denominator, or you can construct with just a numerator and it assumes the denominator is 1. So if you want to make a fraction that's actually a whole number, you don't have to say 15 comma 1. You can just say 15 and it'll treat it as 15 comma 1. So pair of constructors. And internally, you know, you're going to have a numerator and a denominator, a pair of integers, and your constructor just basically gives those values. Okay, so most of the interesting work is these 4 functions: add, subtract, multiply, and divide. And this is how you manipulate fractions. So for example, I could say the following. Fraction h equals new fraction 1 comma 2. So h should be the fraction 1/2. Fraction, I'll call it 2, equals new fraction 2. So 2 is the fraction 2 over 1. And I'm going to make a fraction temp. So I can say something like h dot multiply by 2. That should take whatever the fraction h is and multiply it by whatever the fraction 2 is. Well, h is 1/2 and 2 is 2, and if I multiply those I should get 1 over 1. So when I finish this, temp should be equal to something with a numerator and a denominator both equal to 1. I could say temp equals h dot add 2. So what should temp be equal to in this case? Math quiz. 1/2 plus 2, right? So
5 over 2.
5 over 2. Cool. So these add, subtract, multiply, divide functions are always returning new fractions, which are equal to the result of doing whatever the corresponding arithmetic operation is. What's potentially weird is that when we do these things, it looks like we're only passing one fraction. What's the other fraction? It's whatever this object is, right? X has got to be a fraction, and so if we say x dot add n, we're saying x plus n. If we say x dot sub n, we're doing x minus n, and so on. Okay, when you can work with that without your brain sort of pushing back a little bit, right, then you're thinking about objects. Okay, until then it potentially feels a little strange.
But we need to do something for the denominator. Have to be different 0.
Oh, 0 is going to be different. Yeah, we're probably going to talk about that on tomorrow. So high level behavior, you can add, subtract, multiply, divide, and you can do things like this. I can say give me a new fraction. I don't know, let's say 2/3. Well, new fraction 2 comma 3, that is a fraction, which means it has an add method, a subtract method, and so on. So I could say dot multiply new fraction 7 comma 5. So this is a fraction which is 2/3 times 7/5. And I can take that whole thing and I can say add, and I can put in a new fraction name, or I could say new fraction and put in an expression, and so on, right? All of these things are objects. As soon as you have an object of type fraction, it's got add, subtract, multiply, divide, and everything else we're about to talk about. Okay, so another method is 2-double. 2-double takes your fraction and converts it to a plain old double precision floating point number. So if my fraction looks like 1/3, right, numerator is 1, denominator is 3, and I say that fraction dot 2-double, that should return a double, which is 0.33333. How do you do that? Just return numerator divided by denominator. Well, convert them to doubles first, cast them, and then divide. Okay, we have a pair of accessors for reading the numerator and denominator, because those are going to be private, because you don't want somebody else coming in and changing these things, right? So if you want to read what the top and bottom are of your fraction, you can use these getters. You had your hand up?
I'm not sure if you discussed how to convert.
Oh, same as in C. So if I is an integer, you can just say parentheses double, and that casts it to a double. Okay, and you want to write a two-string method, so that if somebody tries to treat your fraction as a string, typically by printing it, it shouldn't just say, you know, fraction @ weird hex number. If your fraction is equal to 1/3, you would like two-string to return something like 1/3. Okay, that's the high-level behavior. That's what all of these functions do. This is what the user has access to. They can create fractions, they can manipulate them, turn them into doubles, find the numerator and denominator, and convert them to strings. The rest of the written assignment is all the details, and we'll go through this more carefully tomorrow, but basic idea of some of the details. For example, if your fraction is equal to 5/1, and you turn it to a string, it should just return 5, not 5/1. Okay, so make it look nice. If your fraction is equal to -5 on top and -1 on bottom, it should return 5. If your fraction is -1 on top and -3 on bottom, it should not print out -1/-3, it should print out 1/3. If your numerator is 1 and your denominator is -3, don't print out 1/-3, print out -1/3. And that's specified in here, but basically make it look reasonable, like what would a person write for a string equivalent of this fraction. The next thing is lowest common form. If your fraction is equal to 16/10, you should actually print that out as 8/5. So how do you convert something to lowest common form? You have to, simplest form, you have to find the greatest common factor. And divide numerator and denominator by that. So how do you find the greatest common factor of two integers? Invisible $1 million bill.
Euclid's algorithm?
Euclid's algorithm, there you go. Invisible $1 million. Yeah, so we'll go over Euclid's algorithm again, but that's how we can look at 16 and 10, and it'll tell us the greatest common factor is 2, so we divide numerator and denominator by 2, and we get 8/5. So that's the second detail. Third detail is division by 0. Because if you make a fraction with a 0 on the bottom, that's got consequences. And we don't want to just sort of leave a 0 there and then do things however they happen to be done. We really want to acknowledge the fact that if you have a 0 in the denominator, that's an undefined number. And we want to avoid things like 1/0 plus something else turning into some valid number, right? We want to know that this is an undefined number and anything you do with it is undefined. So there's more descriptions down here how to deal with that. And then there's descriptions of the grading I'll do. And then back to your original question, how do you test this? So here's a sample main program you can use to test your fraction class. Don't rely on this, right? Write your own test code also. But if you have a fraction class, right, this creates a fraction A, which is 1/2, a fraction B, which is 4. Define some temporary fractions C, D, and E. And each of these print statements prints out something that looks like a fraction, colon, and then it calls the two-string method on a fraction. This should print out 5/2, colon, 5/2. 1:1, 9/2, colon, 9/2, and so on. So I've set up these test cases to print out whatever you see on the left of the colon. So that's one way to test, and it does some division by 0, it does some 2 doubles, and a lot of simplification and so on. But this is not your first test program, because if you're not getting the right answer, you have no idea where it is, right? So build this up in steps, right? Start with the multiply function. Multiply is easier than addition, right? But we'll go through how to add and multiply fractions tomorrow. But just start off with a constructor, numerator and denominator, and write a simple 2-string. Forget about all of these embellishments, right? Just print numerator / denominator. And don't worry if it looks weird. And then try to write a multiply method. If you can get that, you've got all the mechanics down. Then it's just writing more of the same code to flesh out the rest of the package. So tomorrow we'll go through all of those details. We'll talk about this more carefully. And certainly any questions, we'll deal with those. Good? All right. Have a good afternoon. I will see you tomorrow.